Hello everyone, my name is Darren. I'm here today with Abby, Riley, and Emily. And before we get going into our presentation, I just want to take a second to thank everyone for coming today and showing interest in our project on Muskellunge sustainability in the St. John River. So before we get into our project up full speed, I just want to give a little context in terms of muskie in the St. John River. So what is a muskie? As you can see from the pictures here, muskie is a large predatory fish, and it's become naturalized in the St. John River. It was first introduced in the 1970s in the headwaters of the St. John in Quebec, and by 2004, the population had become numerous enough to start angling consistently, and then by 2012, the fishery started to gain national recognition. So the presence of muskie in the St. John River is a highly polarizing topic. Many people have strong opinions about this. And it brings with it certain challenges and opportunities. One of the main challenges would be, what impacts does the muskie have on native species with its presence in the river? So that's something people voice over and over again, and is a large concern. And additionally, on kind of the other side of the fence, we have anglers who want to protect the muskie. They're concerned about the regulations and how sustainable they are. So there's the two type of kind of conflicting ideas going on there. And then for opportunities, we have a chance at having a really high quality fishery that's going to deliver many social and economic benefits, and a function and a sort of measure of ecotourism, as it'll bring in non-resident anglers. So now back to our project. This is our study area. It's a 80-kilometer stretch of the St. John River from the Grafton Bridge here on the top left to the Mattaquack Dam here in the bottom right. And this is located in southwest New Brunswick, which you can see in the inset map here in the top left. So this is going to be our outline for the rest of the presentation. I'm going to go over a quick project overview where I talk about our overarching goal, as well as some of the research questions we wanted to answer during the course of the project. And then we'll get into how we took stock of the fishery through a baseline estimate, as well as a stakeholder survey, and how we took that data and put it into our population model to assess the future of the sustainability of the fishery over various types of angling pressure. And then we'll finally get into what those implications mean and how to improve them. So our overarching project goal is to have a healthy, sustainable population of muskie in the St. John River. And so what do we mean by sustainability? Well, we mean stability in the population. Like you see here on this graph on the left, we have these small oscillations around a central carrying capacity point. And to us, that indicates sustainability. What we don't want to see is this graph on the right. We have more of a boom-bust cycle of population. We have these periods of rapid growth and quick die-off. And to us, that represents instability. And if we were to increase angling pressure on one of these valleys in the graph, we could ultimately end up crashing the population. So these are the research questions we primarily wanted to answer through the course of the project. The first being, is the current management sustainable for the population? Under current regulations, you can harvest up to 5 fish per person per day on anywhere from 4 inches to 60 inches. We want to see how the population is growing under this management style. And then second, we wanted to assess where the population is in relation to carrying capacity. Is it up close near its maximum limit around carrying capacity, or is there a lot more room for the population to grow? And then finally, we wanted to look at and answer if the population will be sustainable for the future. We've had a lot of concerns about increasing angling pressure and the effects that'll have on the fishery. So we wanted to see how that would play out over time. So this is essentially a roadmap of the work we did throughout the course of the project to assess the fishery. Starting with a baseline estimate where we looked at how many fish there are, where are they, and what sizes. And then we used a stakeholder survey to estimate current and future fishing demand. And like I mentioned earlier, we took a combination of those types of data, put it into our population model to model simulations of angling pressure increases over time. So now I'm just going to get into a bit about our baseline estimate. So as you can see here is our project area once again, and in the upper left corner we have highlighted the Sonar Survey area in purple. which is about an 8-kilometer stretch from the Grafton Bridge to Bulls Creek near Woodstock. So the first part of the sonar survey was to get GPS location data from muskie we identified from the boat, which you can see here on the left. We then put those points on top of May's bathymetry data, so May's being the Mactaquac Aquatic Ecosystem Study, and you can see that here in the center. We noticed there were some interesting aggregations of the points around the submerged topography, which you can see here in the bottom center. So we decided to stratify the river based on this submerged topography, which you can see here on the right. So what do we mean when we say stratify? Well, we're breaking up the river or stream in terms of its distinct habitat types. So as you can see here, we've broken those up, the Riffle Run Pool as an example. And from here, you can now get a measure of the area that each strata occupies, as well as the density within them. So this is our baseline estimate results. What you're seeing here is a table showing muskie density, total area, and fish by strata type, with our ultimate result being 401 fish, approximately 30 inches or greater. And we use this data as a starting point for our model, sort of the baseline population, as well as to fill the stocks for different age classes in our model. Gathering this type of data allowed us to extrapolate from the sonar survey area up to the full length of the river, and ultimately allowed us to estimate, get an estimate of the spatial distribution of the fish. So what you're seeing here is, again, our study area with our predicted spatial distribution of muskie. And this kind of visualization is useful because we can see how the abundance of fish changes over the course of our study area. And then finally, just to kind of hammer home how we did this, we again found the density for the strata, multiplied that by the area to get the total number of fish. So we talked about how many fish there are, we talked about where the fish are, and now we're going to talk a little bit about the length of the fish. So what you're looking at is a length distribution from 2007 to 2020 by frequency. And we compiled this data from the totality of the angler logs and the tagging data we could find on the St. John River. And in the literature, these types of distributions are used to approximate upper size classes of the actual population. And then the key message here is the story of the data over time. In the beginning, in the lower part of the graph, we see the lighter areas. There's not a lot of fish being caught. There's less angling interest. And then as you get from 2010 to 2015, there's a dramatic increase in catch and angler interest. And as we hit about 2016, this really starts to level off and sort of normalize. And this sort of normalization, we are inferring as the population at or approaching carrying capacity. And so what you're looking at here on the left is that exact same data summed by year. So it's the total catch over time. And then the graph on the right is the fishing effort curve, so rod hours over time. And when we add that stability line in 2016, we can see the curves are almost identical. And so we're inferring, again, from this that if the population was growing significantly, you would start to catch more fish for the same effort, not equivalent fish for the equivalent effort. And from this inference, we are gathering that the population is at or approaching carrying capacity.
Now we're going to touch on fishing demand. This consists of conducting a stakeholder survey in order to determine current and future angling pressure in the province. In order to identify the increased potential of angling pressure, we first need to identify the current amount of anglers in the province, and we also needed to identify the potential harvest that's happening in the province, since harvest is currently allowed in our regulations. Then we needed to identify the future fishing pressure by determining how many potential new anglers we're going to have in the province. And since this fishery is considered a potential world-class fishery, we do need to consider that there will be an increase in non-resident anglers as well, so that needs to be factored into the future fishing pressure as well. And finally, of these new anglers that are coming in, both resident and non-resident, we need to account for the potential future harvest as long as regulations don't change for the province. In order to determine both of these fishing pressures, we conducted a stakeholder survey. We conducted this survey through Facebook and email, and our main target audience was the angling community. However, we didn't exclude any responses from non-anglers simply because this is a natural resource that is being managed for the general public, and therefore general public does deserve to have a say in how this resource is managed. The survey was posted to a number of angling sites, a couple of Fish and Wildlife professional pages, as well as a number of personal pages. We focused on New Brunswick pages specifically. However, we also posted the survey to angling sites in Nova Scotia, Prince Edward Island, and Maine in order to gather responses from the most likely potential non-resident anglers that would be willing to travel to our province. The professional networking pages that we posted to were Canada-wide, but did also include members from the northern United States, so we do have responses from all of those areas as well. For the New Brunswick pages, we specifically reached out to non-governmental organizations, different clubs, and also private sector jobs pages. And these include Fredericton Fish and Game Club, Canadian Rivers Institute, and the Hammond River Angling Association. In total, we had 677 responses from our survey from a wide variety of demographics. We had age variance between under 19 years old all the way up to over 65 years old, and education levels anywhere from high school diploma or GED equivalent all the way up to a postdoctorate degrees. As you can see from the two maps on the right, we had responses from all across Canada with the exception of Newfoundland, Labrador, British Columbia, and the Territories. We also had responses from 12 different states, mostly focused on the northeastern states, but we did have responses from Tennessee. We asked 27 questions, a variety of these thematic questions, in order to gain understanding of the respondents' understanding of regulations, fishery management, climate warming on fisheries, as well as overfishing. We also asked about their concerns about muskies in the river and whether or not they would travel to New Brunswick to fish for muskies if they were a non-resident. All of these were used to determine if there's any major trends in the data that we collected. Based on the responses we got, we determined that 12% of people currently fish for muskies. Keep in mind, this includes both resident anglers and non-resident anglers that have currently traveled or have previously traveled to the province. We expect this number to increase because Muskies Canada does have a chapter within our province, and based on that, they are doing a lot of advocacy and teaching people about the fishery, how to properly handle fish, and getting more people interested in this fishery. Based on our results, we expect the 12% to increase to 84% interest in the future. One thing to keep in mind, like I said before, this number also includes non-residents as well. And people don't always do as they say they're going to do, so this is not an absolute number, this is just a relative idea. We specifically asked non-residents to identify themselves, and then we asked them to indicate if they would be interested in traveling to our province to fish for muskies in the future. And 92% of the non-residents that we surveyed said that they would be. We have to keep in mind that this could include anglers that have already traveled and are just continuing their interest in the future. They may not all be necessarily new anglers. As I mentioned previously, harvesting is a big concern for muskies because studies suggest that they're much more sensitive to increased mortality. And based on this, we had to ask anglers whether they have harvested muskie in the past or whether they are interested in harvesting in the future. Our responses indicated that 3% of respondents have harvested muskies in the future, and this is expected to increase to 15% in the future. Although this number isn't huge jump like we see in our fishing, we do have to consider that muskies can be more sensitive, therefore this may be a significant increase for them. Finally, all of our statistics that we found lead to a predicted increase in muskie fishing in the province of New Brunswick, and this needs to be considered in future regulations changes.
All right, so now we're going to get into the population model. So a significant challenge that we have faced is that we don't have a complete empirical data set to understand the population's distribution or their dynamics in the St. John River. We know even less so how it will respond to the expected increase in possible fishing pressure that we discovered through the stakeholder survey. In order to help us determine certain elements of the population and to better manage muskie in the future, we have spent the last 8 months building a dynamic population model. So what the model aims to do is to test the resilience to an increase in mortality in response to an increase in angling pressure that accompanies the growth of the muskie fishery in New Brunswick. The way that it works can be seen in this chart. So we took the available empirical data, which included our baseline estimate, the tag data, as well as the angler logs for muskies and B. So with the empirical data, we obtained age class distributions as well as mortality rates for mature muskie. We also had to conduct a literature review in order to fill in the data gaps. So the literature mostly came from the muskie trophy fishery in Wisconsin, but also included literature from Ontario, Tennessee, and Quebec, and then we determined its relevance to the St. John River. So with the literature review, we determined the fecundity rates of female muskie as well as juvenile mortality rates. So we used the births, the growths, the mortality rates, as well as carrying capacity, and we combine these to make a model that looks like this. So we built the model using the Stella modeling software. The model is based on 1-year age classes at 1-year increments for both male and female muskie, as we model those separately. In the inset right here, you can see the stock for female muskie age 9 and 10. So the stock represents the current population at that particular year. The inflow that is adding muskie into that stock is growth. So whatever survived from age 8 will move on to age 9, and then the cycle continues from there. The outflow that is removing muskie from the stock is mortality. So this is an annual mortality rate and only includes natural mortality. The reason you don't see immigration or emigration represented in the model is because muskie tend to have small home ranges and they don't typically travel farther than 10 kilometers on average. So we just assumed that this is a null factor, especially for our study area, which is about 80 kilometers in length. So the ultimate purpose of the model is to estimate the change in population over time under varying regulation changes. So these two graphs right here show this change under 2 different additional mortalities. So that is 10% additional mortality and 30% additional mortality. So in the very first line, you can see there, the green one, that represents the baseline. So the baseline is showing how the population would change over time under a 0% additional mortality. So this does not have any angling pressure on that particular population. The first regulation scenario that you can see in the yellow there is status quo. So status quo represents the current regulations that are in place. So in this scenario, we implemented an option to harvest across all muskie between 4 inches and 60 inches. So this retention size is what is currently legislated by the government of New Brunswick and what is currently enforced. The second regulation scenario that you can see is in black. So that is catch and release. So this scenario does not have an option to harvest, and therefore it doesn't have any retention sizes associated with it. So we modeled this scenario by decreasing the mortality rates on all stocks of muskie, but still included a small incidental angling mortality that still accompanies catch and release fisheries. The third scenario that you can see which is represented in blue, is slot size. So the new slot size would target muskie that are 30 to 40 inches, and this is more in line with other fisheries from Canada and the United States. So as you can see in all three of the regulation scenarios, with the increasing mortality, we see a new carrying capacity being established. And noticeably, even in status quo, there are oscillations that tend to kind of fluctuate around this new carrying capacity. So overall, catch and release and slot size have more stability and resilience when there are increasing mortalities thrown at it, whereas the status quo tends to have a more unstable reaction in terms of population change over time.
So what does this all mean? What are the major implications and conclusions that we've drawn throughout the course of our project? First and foremost is that we believe that current management practices of the 5 bag limit and 4 to 60 inch retention size is working for the current amount of angling pressure going on in the province. Throughout the course of studying the data, there was no evidence of these unsustainable boom and bust cycles that was outlined by Darren at the beginning of the presentation. Therefore, we believe that the current system is working. Second point is that we believe that muskies above the head pond appear to be reaching their carrying capacity at around 400 fish. Again, looking at the data, there was no continuous increases in muskies caught or continuous decreases in the amount of muskies caught. Therefore, we believe carrying capacity is being approached, and we believe that this is another point that drives home that current management practices are working here in the province. Finally, we would like to acknowledge that as angling pressure increases in the future, as is expected to occur based off of our survey data, that regulations may need to be revised. Based off of our model analysis, we saw that at 30% additional mortality, our status quo, or the current management practices here in the province, started to become significantly more sensitive in comparison to the catch and release and slot size scenarios. Therefore, with the high interest in the future of the muskie fishery here in the province, we believe that current management practices may not be the best long term. Now, just highlighting some additional fisheries concerns that we've compiled over the course of the project. First being ecological impacts, specifically muskie impact on native species. We don't really know the degree that muskies are impacting native species here in the province. There is suggestion in the literature that it's based off of the size of the water body as well as the diversity of forage fish. The St. John is quite a large river, and there is suggestion in the literature that it's one of the most diverse rivers here in Atlantic Canada. 2011 report on forage fish diversity showed no changes in forage fish abundance. Therefore, while we might not understand completely the degree to which muskie are impacting native species, we don't believe at this point in time that it's severe. Now, specifically regarding salmon, as it is a concern for a lot of major stakeholders, we do believe that there is limited habitat overlap suggested in the literature. The most interaction that you would see between the two species is during the spring and fall smolt migration. And during the spring smolt migration, we do see that this lines up in time to when muskies are spawning. Therefore, we do believe that they're a little busy doing something else. So the most overlap we would see is during the fall smolt migration. Based off of this, we do not believe that there is significant overlap or significant impacts to salmon populations. Now, looking at largemouth bass impact on muskies, largemouth bass are an established population here in the St. John River after they were first found here in 2014. They are found in our study area above the head pond, and there is suggestion in the literature that they do feed on muskie young, therefore impacting juvenile survivability. This could pose a problem to muskies long term, especially as these two the interactions between these two species are not understood. And therefore, we believe until this happens, the impact largemouth bass has on muskies needs to be taken into consideration when thinking about the levels of additional mortality that muskies will be facing in the future. Now moving on to mercury. For those who don't know, mercury does occur in the ecosystem. It occurs in increasing amounts, especially in terms of anthropogenic activities, and it bioaccumulates throughout the food chain. So what that means is that as you move up the food chain, you'll see increasing amounts of mercury. As we've stated, muskie are at the top of their food chain. Therefore, there is evidence that it is believed that they have higher levels of mercury content. Throughout the course of our project, we've looked at preliminary maze data that shows warning signs of elevated mercury content in fish in the head pond. Therefore, we would just like to drive home the point that if you are going to harvest and consume muskie, that you should adhere to Health Canada protocols. The final point that we would like to address is the education component. There is a lack of knowledge when it comes to muskies here in the province, that they're even here, what that means to the ecosystem, and the handling and fishing techniques. This can become problematic, as if people don't know how to properly handle them, this results in increases in incidental mortality, which we don't want. Therefore, our group has produced an educational campaign poster that kind of outlines a lot of the factors I just mentioned, as well as designated some further resources if you were interested in fishing for muskies here in the province. Now, finally, we would like to address some future improvements that could be made to the project over time. The first being data gaps. There is a general lack of muskie knowledge across the field. This is in terms of birth rates, as well as death rates in terms of natural mortality, as well as fishing mortality. Therefore, to improve muskie knowledge and therefore build upon this project and muskie knowledge here in the province, more studies should be undertaken. Another improvement that we would like to acknowledge is the improvements that could be made to our data set. We do acknowledge that the data set that we used to populate the model had its limitations. This was the angler logs and the tagging study that was undertaken by Muskies New Brunswick. There was no quality assurance or quality control done for these data sets. And we do acknowledge that there is a reporting bias for the anglers here in the province. We know the guys like to record the big fish that they caught rather than the smaller ones. So therefore, we believe more scientific research could be helpful. Then in terms of improvements to our model, we want to acknowledge that the resulting analysis that we did underestimates the impact of the additional mortality. Therefore, we want to really drive home the point that our resulting curves in our model analysis should be taken relative to one another rather than looking at the absolute abundance. And the ways that this could be improved is, again, filling the data gaps. Finally, we would like to look towards the future for muskie angling in New Brunswick. The future seems to be quite unknown. It seems like there is a high interest, and therefore we need to really understand what that means. We don't know what the current level of fishing pressure has on the current levels of mortality of muskies here. Therefore, it's impossible for us to draw any hard conclusions or predict what the future amount of angling pressure will have. We don't know if the relationship between fishing mortality and fishing pressure is a linear relationship or whether it's exponential. Therefore, to avoid decimating the muskie population, this does really need to be understood. So just to wrap up, some acknowledgements of the people who kind of brought this project to where it became. Obviously, Muskies Canada, Muskies New Brunswick, Department of Natural Resources. We had some help from a gentleman in the States, Matthew Faust, lots of help from CRI, as well as the professors here at the university who kind of really helped us along throughout the entire project and helped make it what it was. So thank you, everyone, and now we'll take some questions.